Here we go for the last day of angles and triangles. So this is lesson number 8. We have been doing triangle proofs. We have been proving that triangles are congruent. Let's do a recap on the ways that we can prove that triangles are congruent. So we've got side, 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 angle, side, angle, side, angle, 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 side. Remember, there's no triple A, there's no swearing forwards, there's no swearing backwards, and then we have hypotenuse leg, which can only be used for right triangles. Okay, so those are the 5 ways that we can prove that triangles are congruent. So that leads us back around to CPCTC, which stands for, do you remember? Corresponding parts of congruent triangles are congruent. So if you have congruent triangles, that means that all of their corresponding parts are also congruent. When we are asked to prove parts are congruent, and what do I mean by parts? I mean sides and angles. When we are asked to when we are asked to prove that parts are congruent, you must first prove that the triangles are congruent. So you have to establish congruent triangles first before you say that the parts are congruent. All right, so the best way to go is to just start doing some proofs. So I'm going to start it off just like always with my given information. So this says that AB is congruent to AD given. This says that BC is congruent to CD given. And my proof is that angle BCA is going to be congruent to angle DCA. So this is a different proof. Every proof that we've done so far has been triangles congruent to each other. This is an angle congruent to another angle. So that is parts. Because this is parts, you need to first prove that triangle, and you can label it just like this, triangle BCA is congruent to triangle DCA. We've got to get our triangles congruent first, and then we can say that their parts are congruent. All right, so let's go ahead and mark it up as always. So I've got AB congruent to AD, and I have BC congruent to CD. Do you see it? It's staring right at you. AC is congruent to AC because reflexive property. Is that enough information to say that my triangles are congruent? What do we have? Side, 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 side. So yep, I can say that triangle BCA is congruent to triangle DCA. I just use the same order of letters. And I can say that because of side, side, side. So for the past 2 days, this is where our proof has been ending, right? We're taking it a step further, and we want to say that BCA let me grab my green highlighter. So BCA is right here. This angle is congruent to DCA, this angle. Well, because these two triangles are congruent, and because these are corresponding parts, I can say that they are congruent. What allows me to say that? CPCTC. I have congruent parts of congruent triangles. Okay, so those guys are congruent. That is the reason why I'm allowed to say these parts, these angle, okay, corresponding parts. This is the reason why I can say those angles are congruent. All right, let's try another one. Givens first, as always. So PS parallel to QR, given. Angle QPS congruent to angle SRQ, given. And my proof is that side length PQ is congruent to side length RS. So because these are sides, which are parts, I have to first prove that my triangle, and I'm just going to borrow the order of these letters right here, that triangle QPS is congruent to triangle SRQ. I have to say the triangles are congruent, and once I do, then I can say that their parts are congruent. Okay, mark it up. So we've got PS parallel to QR, and we have QPS, that's this angle, congruent to SRQ, that's that angle. All right, what next? Well, some of you are saying, I see it, it's right here, QS is congruent to QS. All right, cool, let's do that. QS is congruent to QS because of the reflexive property. Okay, now what? I don't have triangles congruent yet. I only have one side and one angle. That means that I have to use these parallel lines. So here's my parallel lines. Here is the transversal. Do you see the angles that are congruent? It's got to be that one and that one. All right, I can't call it angle S because there's two different angles there. So I have to call it PSQ, angle PSQ is congruent to angle RQS. And how do I know what kind of angle pairs are those inside of parallel lines? Those are alternate interior angles. Alternate interior angles are congruent. Now, do we have enough information? Cover up and look at one triangle at a time. What do we have? I've got two angles followed by a side, two angles followed by a side. So that allows me to say that the two triangles are congruent because of angle, angle, side. So triangle QPS is congruent to triangle SRQ because of angle, angle, side. So now, can I say that PQ is congruent to RS? I sure can, because those are corresponding parts, and I already said that my triangles are congruent, so corresponding parts of congruent triangles are congruent. CPCTC. Remember, be pausing me, work ahead, do these on your own. You're doing it from the safety of your desk or your bedroom floor, okay? Do them on your own and then play me and see how you did. Fix your answers if you got something a little bit wrong. All right, X is the midpoint of WY and VZ given. We want to prove that angle XWV is congruent to angle XYZ. But before I can say that those parts are congruent, we're gonna have to say that the triangles are congruent. Before I can say parts, I have to say triangles are congruent. All right, let's mark. X is the middle of WY. Well, that makes this one and this one congruent. So I can say that WX is congruent to XY. How did I know? Well, X was in the middle, which means that I know the definition of midpoint. It also says that X is in the middle of VZ. So that gives me that piece and that piece congruent. So VX is congruent to XZ, same reason, definition of midpoint. What else do you see? You see that X right there? What do I know about those angles that are across from each other in an X? I know that they are equal or congruent to each other. So WXV, angle WXV, is congruent to angle ZXY, because what are those called? Vertical angles. And now, do I have enough information to say that my triangles are congruent to each other? Look, one triangle at a time. What do we have? Side, angle, side, side, angle, side. So yep, side, angle, side says that the triangles are congruent. What allows me to say that the parts are congruent? CPCTC. Hopefully, since we've done quite a few of these are getting a little easier and a little easier every time we go through one. Pause me, do it. You can do this one. JM bisects angle KJL given. Angle JMK congruent to angle JML given. And we want to prove that side JK is congruent to side JL. But in order to say that parts are congruent, aren't we going to have to say triangles are congruent? I'm just going to borrow the order of these three letters because I know that they're right. Triangle JMK congruent to, triangle KJL. Before I can say parts, I have to establish triangles. All right, did you mark it? JM bisects angle KJL. What does it mean to bisect something? It means cut it in half. It means two equal angles. That's what that means. All right, what do I need to call it? KJM, angle KJM, congruent to angle LJM. How did I know? Because I knew what the word bisects means. So this is the definition of an angle bisector. All right, what else do you see? Right down the middle, you see it? Right there. What do we write? JM congruent to JM. That is the reflexive property. Oh, and I forgot to mark it like that. Oh shoot, what else did I forget to mark? I forgot to mark number 2. Number 2 said that angle JMK, so that one, and JML, that one. All right, did I remember everything? I got bisects, I got that angle, I got the reflexive property. Okay, let's take a look. Why are these two triangles congruent to one another? Because of angle, side, angle, and angle, side, angle. Now that my triangles are congruent, I can say that the parts are congruent. CPCTC. So that is where we were ending the past couple of days, and now we're adding on one more line. So we're not stopping with triangles, we're using triangles to say that their pieces that we didn't know were congruent, in fact, are congruent. All right, last one. Let's go BC parallel to EF, given. D is the midpoint of BF, given. And I need to prove that ED is congruent to DC. Those are parts, and before I can get parts, I need triangles. Well, I'm gonna have to label my triangles on my own because I don't have 3 letters to steal. Okay, so what do you wanna do? How about EDF? Congruent to triangle, well, let's see, E's tiny, so that means C, and then D, and then B. All right, let's mark. BC parallel to EF. D is the middle, oh, this way, is the middle of BF. So that means that guy and that guy are congruent. BD congruent to DF. And how did I know that? Because we know the definition of a midpoint. All right, so I only have a side. That is it. Let's use these parallel lines. So if these are my parallel lines, and let's say that this is my transversal, what do we got? We've got angle B and angle F congruent. So angle B is congruent to angle F. And how did I know that? What kind of angle pairing is this in our parallel lines? Those are alternate interior angles. Okay, what else? I've only got an angle and a side right now. So what else do you see? Could we use that, vertical angles, to say that this one and this one are congruent? Sure can. Was that BDC congruent to FDE? And those are vertical angles. I want to point out, actually we're good. It's good. Okay, so is that enough information? Do I have 3 parts? I've got an angle, a side, and an angle, a side, and an angle. So that is angle, side, angle. And now that my triangles are congruent, that means that all of the corresponding parts are congruent. So corresponding parts of congruent triangles are congruent. All right, let me go back to 2 days ago, that kind of graphic organizer that I gave you, right? With all of the ways, all 5 ways that we can prove that triangles are congruent. Okay, some common reasons that we use for different sides and angles. And then right at the bottom, CPCTC. Corresponding parts of congruent triangles are congruent. So if ABC is congruent to DEF, that means that angle A is congruent to angle D. It means that angle B is congruent to angle E. And it means that angle C is congruent to angle F. So 1 and 1, 2 and 2, 3 and 3. So those corresponding angles. Well, we can do sides as well. So this means first two letters AB congruent to first two letters DE, boom. And then second two letters BC congruent to EF, there and there. And then first and last letters AC congruent to DF. That and that. Okie dokie. So we are done with our unit. You can look forward to some practice on this, and then we will review, and then we will have our test on this unit very shortly. See you soon.